Hey everybody, this video is finding the limit with a rational function. So if you notice, I have the same exact expression here, but we're going to find the limit as x approaches 6, and we're going to find the limit as x approaches -4. So the places that are concerning about a rational function on the graph are the vertical asymptote and if there's a hole in the graph. And you should have gone over this last week, finding key features of rational functions. So in order to find those, we have to have the factored form. So again, if you're still struggling with factoring, come to office hours, go on iExcel. If you log into Clever, iExcel is under the district resources, and there's a bunch of probably factoring topics that you can do in iExcel. Or it's a super common topic. If you just Google factoring trinomials, I bet a bunch of videos are also going to pop up. All right, so I'm going to go through the factoring process quickly for these. This factors into x plus 4 and x plus 2. This factors into x minus 6. And x plus 4. So we need the factored form of the numerator and the denominator. So before I answer the limit question, I want to look at the factors of my denominator and figure out which one is a vertical asymptote, which one is a hole. Are they both vertical asymptotes? So I can tell here the number that makes this factor 0 is when x is equal to 6. And I can tell this one, the number that makes this one equal 0 is when x is equal to -4. Because those cancel, this one will be a hole in the graph. Because this one does not cancel, this one is a vertical asymptote. So I have a vertical asymptote when x is equal to 6. So I'm not going to sketch the whole graph yet because I want it to be a little bit more accurate. But if you look at the different types of discontinuities that we have, and if you look at the examples of finding a limit from a graph, whenever your graph is approaching an asymptote, the limit does not exist, because one side is going to be going up to positive infinity, the other side is going to be going down to negative infinity, or even if it was both infinities, even if they were both pointing up. Whenever there is a vertical asymptote, the limit does not exist. So because when x approaches 6, and 6 is a vertical asymptote, the limit does not exist. Now a hole is a removable discontinuity. So the limit does exist at a hole. So I can already tell from this one that this is going to be the hole when x is equal to -4. And so I need to find out exactly where that hole is. So I'm going to be using the simplified version of the fraction. And we need to plug in -4 for x so that we can find the y value of that hole so that I can plot that point. So the numerator, denominator, that reduces to 1/5. So I have a hole on my graph at the point -4 and 1/5. So just bear with me here, pretend that this is a good scale. So I have a hole there. All right, so more than likely what this graph looks like is something like this. So the limit does exist at a hole because the left is approaching the hole and the right is approaching the hole. So they're meeting at the same answer. Even though they're never going to actually equal that number, they are approaching that number and getting infinitely close to that number. So the answer to this question is 1/5, because that's the y value of the whole. All right, so here's another example. All right, and again, this is the same expression, I'm finding two different limits. So I want the factored form. I wish I have a little bit more room on this one. So this factors into x plus 1, x minus 5. That factors into x plus 1, x minus 5. So if I'm looking at my denominator, I can see for this factor, if x is equal to -5, that will make that factor 0, so that's something. And for this factor, I can see when x equals 5, that is also something. So because this one's cancel, when x equals 5, there's a whole. Because this one does not cancel, there is a vertical asymptote there. Actually, I did not leave myself enough room. So I'm just going to sketch the graph here. All right, so at -5, I'm going to have a vertical asymptote, which means the limit as x approaches -5 does not exist. You cannot find the limit at a vertical asymptote. The ends do not approach an actual value. All right, but this one is asking me to find the limit when x is the whole. So I can find that. I just have to find the y value of the whole. So I'm going to use the simplified version. And I'm going to plug in 5. So 6/10 reduces to 3/5. So I have a hole in my graph at the point 5 and 3/5. So this graph probably looks something like this. All right, so I can tell from my hole that the limit does exist because the left part, as you approach from the left and as you approach from the right, they're going to approach that same y value. So to answer this first question, the answer to this is 3/5, the y value of the whole. All right, since those are the only places on the graph where the limit could be, does not exist, if this asked you to find the limit as x approaches 1, you would be able to just plug 1 right into this. The only time that we have to kind of go through all this work is if they're asking us to find the limit as x approaches a whole or a vertical asymptote. So to kind of sum it up, the limit as x approaches a whole is equal to the y value of the whole. The limit as x approaches a vertical asymptote does not exist. And the limit as x approaches any other number, any number that's not a whole and not a vertical asymptote of the graph. To find the answer to that, you just plug in the number for x. And whatever it equals is the answer to your limit.